Hello everyone and welcome back. In this video we're going to talk about testing for a difference between two proportions. When we want to perform a hypothesis test between two proportions, we typically assume that there is no difference between them. And so this tells us that the null hypothesis is P1 minus P2 is equal to 0. So there is no difference between the two proportions, and this is equivalent to saying that P1 is equal to P2. Now in the last video we derived the standard error formula, which involves using the sample proportions P1 hat and P2 hat in the calculations. Now because we assume that the null hypothesis is true, then this tells us that the two proportions are equal. Therefore, there should only be a single proportion in this standard error formula. But which proportions should we use? Well, the answer is that we should use both of them. So whenever we have data that comes from different sources or different groups that is believed to be from the same underlying population, then we can combine these successes to obtain an overall proportion. And this is referred to as pooling. Now, if we are given the counts from both groups, then we can find the pooled proportion by taking the sum of the successes from both groups and dividing it by the combined total of the sample sizes. But if we're given the proportions and not the counts from each of these groups, then we have to reconstruct the number of successes by multiplying the sample size by the sample proportions. And then we typically round these to whole numbers. So once we have calculated the pooled proportion, we can then substitute this into the standard error formula for both P1 hat and P2 hat. So we obtain this as a result. And so now the pooled standard error, after some simplifications, ends up being this formula. And so this is what we'll use to calculate the standard error when we perform a hypothesis test. So this is called a two proportion Z test, and the assumptions and conditions are identical to the two proportion Z interval. And so we test a hypothesis where we assume the proportions are equal, and mathematically this means that P1 minus P2 is equal to 0. We find a pooled proportion from our data, and then we use this to calculate the standard error. Then the test statistic is calculated by taking the sample estimate of their difference, which is P1 hat minus P2 hat. We subtract the hypothesized difference, which we assume to be 0, and then we divide it by the pooled standard error. And so our test statistic will be a z-score, and so we'll use the standard normal curve to obtain the p-value. So let's take a look at an example. Suppose that the lottery commissioner's office in a state wants to find if the proportions of men and women who play the lottery are different. So we take a random sample of 500 men and find that 160 of them play the lottery, and in a sample of 300 women, 66 of them play the lottery. So let's carry out a hypothesis test at a 1% significance level, and can we conclude that the proportions of all men and women in this state who play the lottery are different? So let's first introduce some notation here. So we're going to let P sub m be the proportion of men in this state who play the lottery, and P sub w will be the proportion of women in this state that play the lottery. And so let's first write down the hypotheses for the test. And so for the null hypothesis, we assume that there is no difference between the two proportions. And we have a choice in how we write the difference here. We can choose to write the difference between the proportion of men minus the proportion of women, or the proportion of women minus the proportion of men. And so it won't make a difference in the end result in which difference we choose. So let's write the hypothesis as the proportion of men minus the proportion of women is equal to 0. And now what we're testing is for any difference in their proportions. And so this corresponds to a two-sided alternative hypothesis. So the difference between the two proportions, piece of m minus piece of w, is not equal to 0. So here we're testing for any difference. So now the next step is to check the assumptions and conditions. So we have the independent responses. And so within each group, a person that plays the lottery should not affect other people playing the lottery. And we also have the independent group's assumption. And so for this case, a man that plays the lottery should not affect a woman that plays the lottery, and vice versa. And so a woman that plays the lottery should not affect a man that plays the lottery. So the groups are independent of each other. And so to check for independence, we look for randomization and the 10% condition. So we're given that we have random samples, and so the randomization condition is met. And the 10% condition says that the sample sizes are no larger than 10% of the population. So we assume that the sample sizes are no larger than 10% of the population. And for sample sizes of 500 and 300, this is a pretty reasonable assumption. And the other assumption is that we need to have a large enough sample. And And so we check for the success and failure condition for both of these groups. So the sample size for the number of men is 500, and the sample size for women is 300. So what we're given is that 160 men play the lottery, and 66 women that also play the lottery. And the remaining 200, or rather 340 men and 234 women do not play the lottery. And so that tells us that there are 160 successes for men with 340 failures, and then 66 successes for women and 234 failures, and all of these values are greater than 10. And so the success and failure condition is met. So the next step is to calculate our test statistic, which will be a z-score. It's given as the proportion of men in our sample minus the proportion of women in our sample that play the lottery over the pooled standard error. So we want to calculate the pooled, or the proportion of men that play the lottery, which is 160 over 500. This is 0.32. And the proportion of women that play the lottery is 66 out of 300. And this is 0.22. Now, in order to find the standard error, we need to calculate a pooled proportion. So we take the number of successes from both groups, so that's 160 plus 66, and we divide by the combined total of our sample sizes, which is 500 plus 300. And this works out to be 0.2825. So now we can calculate the pooled standard error, which will be the square root of the pooled proportion times 1 minus the pooled proportion, and that's multiplied by 1 over the sample size for men plus 1 over the sample size for women. So we have the square root of 0.2825 times 1 minus 0.2825. That's multiplied by 1 over 500 plus 1 over 300. and the standard error is approximately 0.03287. And now we're ready to find our test statistic. So we take the sample proportion in men, which is 0.32, minus the sample proportion in women, which is 0.22, divided by the standard error, which is 0.03287. And rounding to 2 decimals, our z-score is 3.04. So now we can calculate the p-value. Our test is a two-sided or two-tailed test because our alternative is two-sided. Which means that the p-value will be the area of both tails under the standard normal curve. And so we calculated our test statistic to be 3.04. And so the p-value is going to be the area of both tails from our test statistic. And so the p-value, because of symmetry, we can calculate the area of one tail and then multiply it by 2. So it's going to be twice the area to the left of negative 3.04. So looking up negative 3.04 in our Z table, we find that the area to the left is 0.0012. And then doubling this, we find that the p-value is 0.0024. And now we'll compare this to the significance level. So since the p-value, which is 0.0024, is smaller than the significance level of 0.01, we will reject the null hypothesis. And since we rejected the null hypothesis, this means that we have evidence for the alternative. So there is sufficient evidence to conclude that the proportion of men and women that play the lottery in the state are different. This concludes our lesson for this video. In the next video, we will introduce a new sampling distribution model and more hypothesis tests for categorical data. And I'll see you then.